by the end of this video, we'll be able to have some questions about random compounds or elements that we don't know about, and we'll be able to predict their properties, namely their melting points and whether they conduct electricity or not. And we're going to do it by building a flowchart. All the types of bonding and structure that I go through, I've made a separate video about where I go into detail about it. This is just a summary where we're going to put it all together. So first thing is, what kind of atom have we got in our compound or element? Two types of atom: metals, which will lose electrons to get their full outer shell of electrons, and non-metals, which will gain electrons. So for type of atom, that's where we're going to start. Metals, non-metals. Okay, excellent. So what kind of bonding do we get? If there's just metals, then those atoms will lose electrons to make positive cations and have these delocalized electrons there with it. We call that metallic bonding. So that's my first type of bonding. Okay, what about if we've got metals and non-metals? Well, in that case, the metal atom will lose electrons, the non-metal atom will gain electrons, and we'll get positive cations and negative anions, and then it's the attraction between those two that bonds it together. That's called an ionic bond. So this is ionic bonding. What about if we've just got non-metals? In this case, the way that they can get a full outer shell of electrons is by sharing a pair or two pairs of electrons, and that makes molecules or giant structures. So that's my last type. Covalent bonding. Okay, then what kind of structures do we get? First of all, in metallic bonding, we get this pattern of cations in a regular arrangement with the delocalized electrons between them. It's called a giant metallic lattice. Second of all, for ionic bonding, we get a pattern of negative anions and positive cations alternating, making this giant ionic lattice. These are 3D structures. Quite similar. Okay, what about covalent bonding? There are two things that we could get. The first one, which is really the exception, is for a few things they make a giant covalent structure. So diamond is one example with this 3D structure, and graphite, which has got the layer structure, and silicon dioxide, silica, sand, has got a similar structure to diamond. So let's write that in. Giant covalent structure, and for this one I'm going to write those three down. Diamond and graphite are both made of carbon atoms. There are other elements or compounds that have giant covalent structures. Those are the three main ones to know, so those are just the three that I'll put here. Pretty well everything else makes a simple molecular structure. So just molecules, this is water for example, a molecule's got two hydrogen and one oxygen atom. That's more common. Okay, those are our types of structures. So what properties do they give? Well, first of all, giant metallic lattice, we've got that attraction between the positive ions and the delocalized electrons, so that gives it a high melting point and boiling point. Ionic bonding, giant ionic lattice, we've got that attraction between the cations and anions. It gives it a high melting point and boiling point. It's very difficult to break that. Giant covalent structures. We've got covalent bonds that we need to break if we're going to melt it. So again, very high melting points and boiling points. And last one, poor molecules. They've got a weak intermolecular force. So that's easy to break. So these are the ones that have low melting points and boiling points. They're the odd ones out there. Last one then, do they conduct electricity or not? Well, metals, the ones we'll be familiar with, have got delocalized electrons to move through the structure, so they will always conduct electricity. It's because of the delocalized electrons. Ionic structures, when they're solids, they have not got a charged particle that's free to move. But remember, if we melted it into a liquid, or if we dissolved it in water, then those ions themselves would be free to move around, and it would conduct electricity because of the ions. So, for that one, alright, yes, but that's only when it's liquid or aqueous, dissolved in water, but no, they don't when they're solid. Giant covalent structures. We've got two different types here. In graphite, there are delocalized electrons, so that will conduct electricity. However, diamond and silicon dioxide don't have anything that will conduct electricity, so they're a no. Last one, do molecules conduct electricity? Molecules do not have any charged particle that's free to move, so they never conduct electricity. Just a flat no. Okay. Just get those last arrows in. Let's use that flowchart then to answer the questions that I showed at the start. I don't know anything about these elements and compounds yet, but I'll be able to use that flowchart to work out the answer to these questions. So first of all, nitrogen tetroxide, N2O4, is that going to have a high or a low melting point? Let's look at our periodic table first of all. N and O are both non-metals. So let's start. Non-metals, they're going to have covalent bonding. They're not diamond, graphite or silicon dioxide, so it's going to have a molecular structure. It's going to be molecules of N2O4. And that means it's going to have a low melting point. So I know the answer to this is it's going to be low. Number 2, does rubidium nitrate conduct electricity? Let's have a look. Right, rubidium is on the metal side. Nitrogen and oxygen are on the non-metal side, so this has got both metals and non-metals. So it's going to have ionic bonding. So it's going to have a giant ionic lattice structure. So it is going to conduct electricity when it's liquid or aqueous, but it's not going to conduct electricity when it's solid. So I'll just write for my answer there, no when it's a solid. Is sulfur hexafluoride solid, liquid or gas at room temperature? So that's about its melting point and boiling point. SF6, let's look for S and F. They are both on the non-metal side, so this just contains non-metals, so it's got covalent bonding. It's not one of these exceptions, so it's going to be made of molecules, and therefore it's got a low melting point and boiling point. If it's got a low melting point and boiling point, then it's most likely to be a gas at room temperature. Okay, is scandium solid, liquid or gas at room temperature? I've not heard of that, but let's look at it on my periodic table. There it is on the metal side, so it's a metal. It's got metallic bonding, a giant metallic lattice structure, and therefore it's got a high melting point and boiling point. If it's got high melting point and boiling point, it's going to be a solid at room temperature. Last one, does ammonia conduct electricity? Let's look for N and H on our periodic table. They are both non-metals, so therefore we've got covalent bonding. It's not one of those three, so it's going to be molecular in structure, made of molecules, and therefore it does not conduct electricity. So the answer we know is no. There you go, we've been able to use that flowchart to predict the properties of any element or compound that we don't know about.